Each and every day, the media fills our heads with numbers. The economy, crime rates, test scores, poll results, and medical studies. It's nearly impossible to get through the day without hearing numbers in the news. When it's not numbers that we're hearing, it's often the results of statistical studies that newscasters and TV show hosts are discussing. Some of the headlines are so poorly thought out that they're funny, while others, those are scary. H.G. Wells once said that statistical thinking will one day be as necessary for efficient citizenship as the ability to read and write. Well, boys and girls, one day is here. The hardest part of statistics is collecting data. Poorly collected data can produce misleading results. Consider the publishing company that is trying to get an idea for a new magazine that will appeal to a certain community. Using their knowledge of elementary statistics, they come up with a simple random sample of residences in that area and call the homes during regular business hours asking about their favorite magazine. The results? Overwhelmingly, the majority of respondents answered Parenting Magazine or House and Garden. The problem? They called during business hours when most people are at work. Stay-at-home moms are most likely to answer the phone during these hours. This sample is not representative of the population of interest, and the results are therefore inconclusive. The publishing company has wasted valuable time and money. Even when appropriate sampling techniques are employed, the questions posed need to be carefully worded not to elicit biased responses. A sample of people were posed the question, researchers at a leading university claim that electromagnetic fields produced by devices like cell phones may cause cancer and other neurological diseases. Do you agree? The vast majority of people in this sample responded with yes. Do you think that the results might differ if the researchers had simply asked, do you think cell phones cause cancer? Certainly. If a leading researcher says it's true, people are likely to agree with that result. Most of us certainly don't know enough about electromagnetic fields to draw a conclusion on our own. Who's going to disagree with professors at a leading university anyway? If that's not convincing enough, allow me to lend an example from my own life. When I was in 4th grade, if someone would have asked me, do you believe in Santa? I would have answered, yes. But when my mom casually asked, Emily, you don't still believe in Santa, do you? Not only did she basically tell me Santa wasn't real, I felt as though I had to answer no. Sometimes bad statistics are produced by the numbers themselves, rather than the collection methods. Careful exploratory data analysis must be done in order to choose appropriate ways to report summarized data. Consider the following true statistic. The average starting salary of geography majors graduating from the University of North Carolina in 1986 was $250,000. Why are UNC geography grads making so much money when nationally graduates in geography are starting at $22,000 a year? Michael Jordan earned his geography degree this year and went on to make over $700,000 in the NBA. You see, the average is computed by taking the sum of the data values and dividing that sum by the number of data values. This measure of center is highly affected by outliers, an individual value that falls outside of the overall pattern of the data. While the average is accurately reported, the statisticians should have used the median or the middle value to report the average starting salary based on the presence of extreme values. Technically, the information gathered in these examples are accurate. They're just misleading to someone who reads the reports and is unaware of the methods used for gathering or analyzing data. Be a skeptic and be educated so that you aren't a victim of bad statistics.